To measure job quality, researchers need to gather data on job characteristics and outcomes to analyze how these two are connected. Instead of looking at individual characteristics and indicators, researchers often compare job types. More specifically, as a first step, researchers list the job characteristics of interest and identify relevant indicators to capture them. In a second step, jobs with similar characteristics are grouped into types. In the third step, different outcomes can be compared across job types. Why is it interesting to work with job types rather than individual jobs or job characteristics? By working with job types, we are able to account for the multifaceted nature of jobs and for the complexity and multidimensionality of job quality. Moreover, combinations of characteristics may have different impacts on outcomes than individual job characteristics. For example, having to do repetitive work is difficult, but it gets worse when this work is done at high speed. There also is a lot of variation. Some jobs score well on some of the indicators but poorly on others, while other jobs score well or poorly overall. Finally, by working with job types, it's easier to look at distributions and patterns. How can job types be identified? In our example, we create a taxonomy based on data from the European Working Conditions Survey, in which we identify individual job characteristics and their corresponding indicators. Then, based on a cluster or a latent class analysis, we can identify clusters of jobs with similar characteristics or similar scores on these indicators, so we group them. For example, jobs that combine low levels of task autonomy and task complexity and high levels of speed pressure are combined into a single job type. We start from the 21 indicators identified in the WES model. Using cluster analysis, in our example, we arrive at 7 job types: active and flexible jobs, balanced jobs, low-strain support jobs, structured jobs, passive unsupported jobs, socially demanding and flexible jobs, and low-quality physical jobs. In this table, we show a number of indicators for each of the 3 categories of the WES model, as well as how each of the 7 job types performs in terms of these indicators. If we look at the W, the work dimension, for example, we see that active and flexible jobs and balanced jobs, on the other hand, score well in terms of task autonomy and task complexity, while low-quality physical jobs perform poorly for all 3 indicators. If we look at the S, the social relations dimension of the WES model, we see that especially passive unsupported jobs and low-quality physical jobs perform poorly. If we link these job types to specific outcomes using regression analysis, we notice that overall balanced jobs and active and flexible jobs perform well in terms of job quality, whereas the opposite is true for the low-quality physical jobs and the socially demanding and flexible jobs. Structured jobs have the lowest incidence of sleep problems, and psychological well-being is highest for workers in active and flexible jobs and balanced jobs. Finally, we can look at distributions and patterns. What workers end up in what jobs? What types are most prevalent in which sectors and countries? Low-skilled workers, for example, are overrepresented in low-quality physical jobs. Managers are concentrated in active and flexible jobs. There are also large differences across sectors and countries, so not all jobs are equally prevalent in all sectors or in all European countries. To sum up, job quality can be assessed with data on job indicators and outcomes. So we combine jobs with similar characteristics into types. We can then assess different outcomes for these job types, and we can look at patterns and distributions. So for example, what workers end up in which job type. In the next video, we will cover policies for job quality. Thank you for watching.